Why we don't remember first years of our lives. Hello, friend. Today we'll discover why we don't remember our first years of life. So the other day I had guests coming over, old family friends that haven't seen for years. And during dinner, we started to talk about how long was the last time we met and how they remember me as a little child. And of course, stories about that time came up. And so they asked me if I remember that when I was 3, I've always asked every guest entering our home if they brought me some treats. And of course, I didn't remember that. So they continued, telling me that I asked for a treat every single guest ever coming to our house. It was a sort fee that I took as a child, and it was funny. They were laughing, but I didn't recall a single thing of that happening. So I tried to remember some other things that happened during my young years. But the memories were so cloudy, and it seems like they merged into one. And I realized, I don't remember my first birthday, I don't remember my first step, I don't remember my first word. And I decided to find out why. To be honest, sometimes I don't remember what I ate the day before. And yet here I was looking for information to answer the question, why I don't remember my first years of life. I thought there might be other people with such questions. So I've decided to share what I've learned and make a video about it. My first one. So let's find out why we can't remember being a baby. My personal first memory is about a toy train I've received for Christmas. It was all colorful and with sounds and so on. I remember being super happy about it. But I was somewhere around 3.5 years old. But what was before that? Can you remember anything before you were 3? Most of people don't. Actually, even Sigmund Freud conducted his own studies about this topic in the early 1900s, and he came up with a theory called childhood amnesia. He blamed the forgetting, as he did everything else, on the repression of humiliating sexual thoughts. Basically, the memories are being repressed so not to injure our psychology. This theory didn't live for long, but the term itself, childhood amnesia, continues to live. And now it is the proper term to describe why we forget our early memories. Science is getting closer to understanding this question, providing different theories. The phenomenon, known as childhood amnesia, has been puzzling psychologists for more than a century, and we still don't fully understand it. At first glance, it may seem that the reason we don't remember being babies is because infants and toddlers don't have a fully developed memory. But babies as young as 6 months can form both short-term memories that last for minutes and long-term memories that last weeks, if not months. In one study, 6-month-olds who learned how to press a lever to operate a toy train remembered how to perform this action for 2 to 3 weeks after they had last seen the toy. Preschoolers, on the other hand, can remember events that go years back. Of course, memory capabilities at these ages are not adult-like. They continue to mature until adolescence. In fact, developmental changes in basic memory processes have been put forward as an explanation for childhood amnesia, and it's the most trusted so far. These basic processes involve several brain regions and include forming, maintaining, and then later retrieving the memory. For example, the hippocampus, thought to be responsible for forming memories, continues developing until at least the age of 7. We know that the typical boundary for the offset of childhood amnesia is 3.5 years. Shifts with age. Children and teenagers have earlier memories than adults do. This means that a 10-year-old child remembers more about their early childhood than you do in your 20s or 30s. This suggests that the problem may be less with forming memories than with maintaining them. Maybe another important factor that we know plays a role is language. From the ages of 1 to 6, children progress from the one-word stage of speaking to becoming fluent in their native language. In our early childhood, we have no language, and that's a big point because we have no words to describe memories with words. For example, when you had your first kiss, you can definitely remember who was it with and how was it, good or bad, in details. So you definitely told someone about it using words to describe the experience, and so forming a tie between words and memory, and it was transferred to your long-term memory. When we describe something, we sort our memory, our new knowledge. For example, presenting a structured essay at school, you'll definitely remember that for some time. But experiments in other mammals with complex brains have proven that the role of language is not the most important at our early ages. Animals such as mice and rats have complex brains, And unlike babies, they don't grow up to develop language skills. Yet they too lose the memories made in infancy, researchers realized. As mentioned before, the secret may lie in the hippocampus, a seahorse-shaped region of the brain that's essential to memory and is also responsible for producing new neurons. So an explosion of new neurons in this region during our early years may be the reason for childhood amnesia. New brain cells might crowd the territory of other neurons or even replace them altogether, which could in turn break or reconfigure the small circuits that likely store individual memories. It's called neurogenesis, the process by which new neurons are formed in the brain. To test this hypothesis, in early 2014, Franklin and Jocelyn, neuroscientists at Hospital for Sick Children in Toronto, transferred baby and adult mice from their shoebox-sized plastic cages, where they'd lived their entire lives, into larger metal cages. In these new containers, they zapped the rodents' feet with mild electric shocks. The mice quickly learned to associate the metal cages with the shocks, stiffening with fear whenever they were returned to those enclosures. Baby mice forgot this terror in a single day. Transferred after a day back into the metal cage, they were relaxed. Adult mice, as expected, remembered to fear metal cages for the rest of their lives. But when the adult mice ran on a hamster wheel after the shocks, thereby stimulating neurogenesis, they started to forget the shocks the same way the infants did. And yes, this is how you boosting creation of new neurons with aerobic activities such as running, cycling, swimming, and even sex. Let's get back to mices. The experiment has shown another interesting thing. When the researchers hindered neurogenesis in infant mice with drugs or genetic engineering, the young animals formed much more stable memories, just as adults. Franklin and Jocelyn have continued these experiments by using genetically inserted green dye on adult mice to reveal that new neurons were not obliterating the old ones. Instead, the older cells remain, their circuitry merely overwritten, which probably explains why the original memories become so difficult to recall. We've all heard that we should avoid stress because it ruins our brain cells, and we only have a certain amount of them we were born with. Well, that's not true. Researchers show that new brain cells and neurons are produced throughout our entire life, even though it slows down when we age. But now you know how to boost that neurogenesis of yours, just having activities we mentioned before. The materials are in the description box. Let me know if you've learned something new, because I sure did. And comment down below your first memory and at what age was it. Stay tuned for more videos, hit that like button and subscribe. See ya on the next one, friend.